In 2024, the Nobel Prize in Physics went to two people who, according to angry physicists everywhere, are not physicists. Computer scientists winning the biggest prize in physics? One famous physicist said if you doubted physics was in crisis, this should make you think. But here's the twist. The prize committee was not confused. AI really is physics wearing a disguise. Let me show you. Our story starts in 1982, with a physicist named John Hopfield staring at one of the oldest toys in science, a magnet. Inside every magnet are billions of atoms, each a tiny compass needle pointing up or down, and every needle nudges its neighbors. Hopfield's wild idea: replace the atoms with artificial neurons and the magnetic nudges with connections. The math stays exactly the same. Physicists describe magnets with energy landscapes, hills and valleys. A system always rolls downhill, settling into the deepest valley it can find. Hopfield stored memories in those valleys. Show his network half a face, and it rolls downhill to the complete pattern. It remembers. This became the Hopfield network, the first neural net that could recall corrupted memories, built entirely from the physics of magnetic materials. Then a young researcher heard about it and could not sleep. His name was Geoffrey Hinton. You may have heard of him. Hinton took Hopfield's network and added something physicists know intimately: heat, randomness. He let the neurons jiggle like warm atoms. The recipe for that jiggling came from Ludwig Boltzmann, a physicist who died in 1906, long before computers existed. Hinton called it the Boltzmann machine, and he added hidden neurons, invisible layers that could learn the patterns behind the pattern. Then the world stopped caring. Funding dried up. They called it the AI winter, and it lasted years. Almost nobody believed. But Hinton kept going. His stacked networks became deep learning, and in the 2010s, suddenly everything worked. Trace the family tree of any chatbot on your phone, and at the very bottom of it, you will find a magnet. Physics gives, and physics collects. Every thought a machine thinks has a price, and it is paid in pure energy. Today, artificial intelligence runs in endless warehouses of humming machines that already consume more electricity than entire countries. One answer from a frontier model burns about as much electricity as a light bulb glowing for 2 full minutes. Now multiply by billions. And here is the deepest law of all. In 1961, Rolf Landauer proved that erasing even one bit of information must release heat. So thinking has a legal minimum price, set by thermodynamics. Yet our computers pay roughly 100 billion times more than that minimum. And the surprise? It is not the math that costs. It is the moving. Shuttling data between memory and chip burns most of the energy. Meanwhile, your brain runs on 20 watts, about 1 dim light bulb, and it still does what entire data centers strain to imitate. So the next revolution may be physical again. Researchers are building networks from light and analog circuits, computing closer to physics itself. Which is exactly where this story began. Hardware that thinks the way magnets settle. AI and physics were never two subjects. Hinton himself walked away from his job to warn us. We are building minds we barely understand. On physics we understand deeply. And the loop closes beautifully. AI built from physics now hunts particles, spots gravitational waves, and folds proteins for physicists. So was the Nobel Committee wrong? The wall between the two fields was always imaginary. Intelligence is something matter does. A magnet remembering its pattern, a gas finding equilibrium, a brain finding a thought. It is all the same story. Energy, rolling downhill. So the next time someone says AI is just software, tell them the truth. Every thought ever thought was physics all along.